There's the picture then. Here's the information. And here's the question. So I've summarized the question here. Let's have a look at it then. So find the x-coordinate of q. Q is the normal at p. P is 3, 2. So here's the parametric coordinates. So you can see this would be 3 when theta is pi over 4. So you get x equals 3. And you get the y value. Cos pi over 4 is 1 over root 2. Squared is 1 over half. 1 over 2. Times by 4 is 2, which is at p. So theta is pi over 4 at p. Okay, so that's that. So dx d theta and dy d theta is what we need. So let's work them out. Is equal to tan goes to sec squared, so it's 3 sec squared, which is equal to 3 over cos squared. Dy d theta. Function of function rule, the 2 comes down to make 8 cos theta. Cos goes to minus sine, so it's times minus sine theta. At p. Dy dx then, gradient is equal to this over this. So it's minus 8 sine theta cos theta over 3 over, which comes up cos squared, so that will make that cos cubed, which is equal to minus 8 sine theta. Pi over 3 is, pi over 4 is what we're looking at, so this is 1 over root 2 and 1 over root 2, so it's power 4 of 1 over root 2. So it's power 2 of 2, which is 4 over 3, minus 2/3. Tap it in the calculator if you need to. So the normal has gradient 3 over 2. So the normal then, at p, is y minus the coordinate, y coordinate, is equal to the gradient of the normal, which is going to be 3 over 2, isn't it? X minus 3. So y equals 0 at q. So minus 2 times 2 will equal 3. I'm going to expand the bracket straight away. Well, I could do or not. I don't think I will. I'll just leave the 3 there. So minus 4 over 3 then will equal x minus 3. So x will equal 3 minus 4/3. 9/3 minus 4/3 is 5/3. So they ask the x coordinate q, which is part A. Okay, so I put it in there 5/3. Now part B, find the volume. Well, the volume of this generated around OX, if we drop this vertical here and we rotate it round, this will be a cone that's generated. So the volume of the cone then is going to equal third pi r squared h. So let's put that in. I'll put it over here. 1/3 pi. R squared is 2 squared, which is 4, times the height, which is 5/3 to 3, 6/3, which is 1/3. 4 pi over 9. So that's the volume of that cone segment there. Now the volume of this whole thing, that volume, which S when it's rotated will be the volume of the whole thing less the cone's volume here. So we're going to do that at the end, but let's get S dashed. I'll call that S dashed. So the volume of S dash then is equal to the integral pi r squared h, isn't it? Pi r squared. Now the radius is the y value squared. That's the height. It's 4 cos squared. So that squared is 16 cos to the 4 times h pi r squared times the height of the cylinder. And the height is delta x dx. And that goes, the slices are taken of these cylinders, slices. It's going to go from when theta is 0, which corresponds to here, through to theta equals at p pi over 4. Theta is 0, it gives x is 0 and causes 4, which is up here. So theta equals 0 to 4, or pi over 4. That's 0 to pi over 4. Now dx is equal to what? 3 d theta over cos squared. 3 d theta over cosine squared theta. So we end up with then pi 0 to pi over 4 of 16 cos to the 4 dx times by 3, and 2 of the cosines will cancel, won't they? So I'm not going to write it down straight away. I've put the 3 there, and cos the 4 over cos squared is cos squared, and the dx can then be replaced by d theta. So it's 48 pi, 24 pi, I'll leave a 2 in there, so it's 24 pi 0 to pi over 4 of 2 cos squared theta in here. Now 2 cos squared theta is equal to cos 2 theta minus 1, so it's plus 1. So it's cos 2 theta plus 1, I think, goes in there. Double angle formula. And I've taken the 48, 24 and left a 2 with it, so I could replace that by that. Now the integral of this, 24 pi, integral of cos is sine, over the 2 of course, plus theta. And that would be between pi over 4 and 0. So that's equal to 24 pi. Top value, sine pi over 2 is 1, plus pi over 4. That's the top value. Minus, and this is both zeros here. So you end up with then 12 pi plus 8 pi squared. So the volume of S then is equal to this volume minus the volume of the cone, which was up here 4 pi over 9. So 108 minus 4 is 104 plus 8 pi squared. That's what I think I've got. I'm just going to check I haven't made a silly mistake. Yeah, a couple of little errors here that I haven't quite sorted out. 24 over 4 is 6, not 8. That helps. So let's put that in. So that's 6 there. That helps. And I also got the volume of the cone not quite right at the other side. 3 pi r squared times h, and the height is of the cone is 5/3 to 3, which is 9/3, is 4/3. So I need to put that in as well. So that's 16 over 9. Just write that in there. 16 over 9. So down here it would be minus 16 over 9. Let's get that tidy. So it will be 108 take 16 is 92 pi over 9. 92 pi over 9 plus 6 pi squared is the answer.